This is 2.6. It's a combination of functions, what we're going to be looking at and exploring. So we're going to be adding functions, subtracting, multiplying, dividing, and then something called composition of functions. So let's look at the common notation, the way we write it. So here I have f of x plus g of x, very first problem, f of x plus g of x. So the shorthand way of saying that is f plus g of x. So you need to be aware of the notation. So if I write this, which most likely I will, you need to know that that means f of x plus g of x. Basically, you're only writing the x once, and it's a good way of combining it together to be f plus g of x. The same thing with subtraction. So again, if I wrote f minus g of x, that means f of x minus g of x. The same thing with multiplication. F times g of x is the same thing as f of x times g of x. And likewise, we have f divided by g of x. That means the same thing as f of x divided by g of x. Again, it's basically, you're not writing the x twice. It's kind of a shorthand way of saying the same thing. So let's actually look at it on the problems that I'll be giving you. So I might give you a certain function, f of x, and I might give you g of x is that. And then I'm going to ask you to find, like this first problem, f plus g of x. Well, f plus g of x means f of x plus g of x. That's what it means. And then so f of x is 2x plus 1, and g of x is x squared plus 2x minus 1, and I'm adding them together. So you basically just combine those two functions together, add like terms. Yeah, the ones cross out. So that would be adding those two functions together. So let's look at f minus g. So f minus g of x is the same thing as f of x minus g of x. Now, be careful with this one because you got to use the distributive property. A lot of students, let me show you what a lot of students will do, and it's actually wrong. So a lot of students will just put a subtraction sign there. But notice you're supposed to be subtracting the entire g of x function. So you need to put parentheses. And then, of course, use the distributive property. And then combine like terms. So negative x squared. Here the x's cross out. And that would be the final answer. Now, finally, if it says then evaluate if x equals 3. So I didn't quite finish this problem. So if you go back and say x equals 3, then you can actually substitute it in. Then evaluate it. Likewise here, if I said x equals 2, then I can evaluate it. Get it that way. All right, let's look at multiplication and division. So here, if I had a multiplication, f times g of x, that means the same thing as f of x times g of x. So f of x is x squared, and I'm going to multiply that by x minus 3. Notice I use parentheses because I'm going to use the distributive property. So x cubed minus 3x squared. Division, we got f divided by g of x. This means f of x divided by g of x. F of x is x squared. G of x is x minus 3. And you can't simplify that, so I'm finished. So here I have g of x divided by f of x. So g of x is x minus 3, and then f of x is x squared. And again, you can't simplify that, so I'm done. Well, just a quick comment. You could actually break this down to, x over x squared minus 3 over x squared. Remember, the whole reason why you have a long division is because each thing in the numerator is being divided by that. So you really could simplify that to 1 over x minus 3 over x squared. But again, typically we would just leave it like this unless I specifically ask you to do some certain task in there. But again, either way is fine. All right, so the composition. So the title of this lesson is basically the composition of functions. So this is, I mean, I want you to know how to do the shorthand of adding, subtracting, multiplying, dividing, but also composition. So what is composition? Well, notice I have this is not a multiplication sign. It's like a small little O, and it just means composition. Basically, you're going to put one function inside of another function. So, for instance, if I had a function, and this is a function box, let's say x plus 2. And if I put, let's say, a 5 in there, well, we replace the x. That's how we normally do it. We replace the x with whatever I'm putting in there. So I would literally put 5, and then plus 2 would be 7. Well, that's what we normally do. Well, what if I'm not plugging in a 5? What if I'm plugging in let's say, a 3x squared minus 9? Well, again, I just replaced the x. See, I'm putting a function inside of another function. So I'm going to take this entire thing and I'm replacing it where the x is. So 3x squared minus 9, and then I still have the plus 2. All right, and then, of course, you can simplify it. So this would be the entire thing. So you can put another function inside of a function. Remember, you can put anything inside of a function. So it's just replacing the variable. That's really all you're doing. So let's look at this example. So here I have f of x equals x plus 2. I have g of x equals x squared minus 4. And notice I have f composition of g of x, which means I am putting g inside of f. So you got to pay attention to this because this one is just the opposite. So what if I wanted to put f inside of g? I actually didn't write the original form here. So this would be like this. So you got to pay attention which one you're putting into which one. So notice here you're putting g inside of f. So start with f. This is what f is. But you're replacing the x variable with all of g. So literally you're taking all of g and replacing the x. So this is literally x squared minus 4. And again, you have the plus 2. So then combine like terms, and that would be your final answer. Now here, notice I'm putting f, the function f, inside of g. So start with g, this is g, but I'm replacing the x with whatever f of x is. So literally I'm putting x plus 2 right here. Replacing the x. And of course, if we FOIL this, remember, you'd write that out twice. You know, x plus 2, x plus 2. And then you're going to FOIL and combine like terms. So this is going to be x squared plus 4x, and then all the numbers actually cross out. All right, so you could put a function inside of a function. Matter of fact, I could actually have f of x. I could put f of x inside of f. So I literally take x plus 2, but I'm replacing the x with x plus 2, which is x plus 4. So you could put any function inside of any function. You're just replacing the x. Go back to the illustration with a function box. You're just replacing the x with whatever I tell you to put inside the function box. And that's 2.6, the composition of functions.